Okay, Assalamualaikum warahmatullahi wabarakatuh. Kami dari Guru Arsenal akan bentangkan tajuk assignment kami iaitu Stokes Theorem. Kumpulan kami terdiri daripada Muhammad Iman bin Ishaq, Muhammad Haziq bin Azizi, saya, Muhammad Ilman bin Muzamani, Muhammad Afizi bin Mustafa Azizul dan juga Ahmad Arif Haris bin Rusli. So, what is Stokes Theorem? Stokes Theorem is a higher dimensional version of Green's Theorem. So, Stokes Theorem is related to a surface integral over surface S to a line integral around its boundary curve. And its Stokes theorem also states that the surface integral of the curl is equal to the line integral of particular vector.
Hi, my name is Muhammad Iman bin Ishaq. So, what is Stokes' theorem? From this figure, it shows that an oriented surface with uninormal vector n. The direction of S causes the positive orientation of the boundary curve C. And then, the positively oriented boundary curve of surface S is often written as del S. Also, if the unit normal vector point upwards, uh, it is the positive value. Then we get the equation iaitu line integral f dot dr sama dengan surface integral curl f dot ds. Curl f juga bersamaan dengan del cross f, ds bersamaan dengan nds. Jadi untuk formula untuk equation surface integral iaitu double integral del cross f dot nds. Ini adalah contoh soalan untuk Stokes theorem. A magnetic field moves with a velocity of f xy equal to minus 2yi plus 2xj plus 4zk and passes through a sphere x square plus y square plus z square equal to 25 inside the cylinder x square plus y square equal to 9. Using Stokes theorem, prove that line integral is equal to surface integral. Jadi, oleh hal yang demikian, kita perlu menggunakan dua kaedah untuk menjawab soalan ini. Iaitu, kaedah pertama, kita perlu menggunakan equation di sebelah kiri, equation line integral, integral f dot dr. Dan untuk kaedah yang kedua, kita menggunakan kaedah di sebelah kanan, iaitu double integral del cross f dot nds, iaitu kaedah surface integral.
Method 1, line integral. So we find the line integral. The answer for the line integral will be the same answer for the method 2, Stokes theorem. Okay, from the equation given, we can sketch solid G and region R for the equation. In the left side, we get the solid G if we sketch from the equation, and for the region R, we sketch it on xy plane, we get a circle radius 4. Step 1, we find RT and R prime T at xy plane. So we substitute the value of Z, which is x square plus y square equal to 9 into the sphere equation. So we get Z equal to 4, which is the radius of the circle on the xy plane region R. Region R on the xy plane. Okay, we continue the step 1, which is R we get 4. So for R prime T, so the x equal to R cos T, and then y equal to 4 sin T, and Z remain Z. So R is 4, so 4 cos T, 4 sin T, and 4. For the R prime T, we must differentiate the equation of R to get the R prime T. So we get negative 4 sin T, 4 cos T, and 0. So we move to the step 2, which is substitute the RT into the equation of F. So equation of F, so we substitute the X with the 4 cos t, and y we substitute 4 sin t, and z we substitute 4. So the answer will be negative 8 sin t, 8 cos t, and 16. This is ft. So next step, we applying the dot product to get f dot dr. So ft we dot with r prime t. So the answer will be 32. Last step, we substitute all the value into the line integral. So ft dot r prime t. So the answer is 32 dt, which is we get from the step 3. So we complete the integral. So the final answer is 64 pi.
Okay, the next one is method 2, surface integral. Hai, Assalamualaikum. Nama saya Ahmad Arif and saya akan explain tentang method 2, surface integral. The step first, determine the curve of f by del cross function of x, y and z. And kita akan dapat 0, 0, 4. Okay, for step 2 is find the unit number vector. First, we found g by using the z equation, then del g, and we use the value of del cross f dot with the del g, and we will get the value of 4. Okay, then the step 3 or the last step, we must change the polar coordinate to do the integration. First, we must find the limit of r and theta and do the integration, and the answer is 64 pi.
And that's it, guys. We made it to the conclusion. By solving this question using method 1, which is line integral, we will get 64 pi. And also solving this question for using surface integral, we also get 64 pi. By using the different method, we can obtain the same answer, which is 64 pi. And this is proven that Stokes' theorem is the surface integral of the curl of a function over a surface bounded by a closed surface is equal to the line integral of the particular vector function around that surface.
Okay, that's all for our group presentation. I hope you enjoy and found this presentation useful. Thank you for your time and attention.